Okay, so we've gotten almost everything we wanted to get off our chest regarding units, systems, ratios, fractions, or whatnot, right? So let's get down to the business of converting some units. Let's say we had the following question. How many blue triangles do you get for 27 blue squares? Okay, now this question can come to you in a gazillion different ways, right? They could write a huge paragraph explaining to you what triangles are and squares are, and giving you a relationship between the two different systems, or they could straight up just ask you convert blue triangles to blue squares, right? And as far as we're concerned, blue squares and blue triangles, they can be anything you want them to be, right? This could be asking you how many milliliters are there in 27 liters of fluid, or 27 gallons of fluid, or 27 quarts of fluid, right? It could ask you how many meters there are in 27 kilometers or 27 miles. It could ask you how many moles of oxygen there are in 27 grams of water, right? It could ask you how much you're going to get paid for 27 hours of work or 27 days of work, right? Anything you want. That's what unit conversion is, going from one system to another system, okay? And as we talked about before, the only way that you can do a unit conversion is if you have a link from one system to another system, and we've already set up our link for the triangles, blue triangles and the blue squares. And what we said was that 2 blue squares was going to be equal to 3 blue triangles. So what we have is the link, the connection we've created between the blue squares and the blue triangles is that 2 blue squares is going to be equal to 3 blue triangles. So what we're going to do is do exactly what we said what we're going to do last time, which is take this ratio, and that's what it is. This is a ratio. We're going to flip it on its side this way, make a ratio, make a fraction with the squares up top, triangles on the bottom, and we're going to do another one, flipping it the other way 90 degrees, and we're going to create 2 ratios and solve this question, answer this question using 2 different equations, and you're going to find out that they're both going to be the same. It doesn't make a difference if we flip it this way or flip it that way. So what we're going to do is take our ratio that we've created here between blue squares and blue triangles and assume and state basically that that ratio is proportional to the ratio of the blue triangles and the blue squares we have in the question, which is a legitimate thing to assume because we set up the problem, right? So what we're talking about is the blue triangles are the same as the blue triangles here, and the blue squares are the same as the blue squares here. If you can think, if you want to think about it, this is the way you can think about it. So basically the way it works is, just like, over here we have a fraction 2 over 10, right? Well, 2 over 10 can be reduced to 1 over 5, right? So what we say is the 2 over 10, the ratio, the fraction 2 over 10 is equal to the ratio of 1 over 5, which is true, right? So we say these 2 ratios, these 2 fractions are proportional. So that's exactly what we're going to do with the ratio that we set up and this question. So what we're going to do is say that 2 blue squares over 3 blue triangles for the top ratio is going to be equal to 27 blue squares over the number of triangles that we're looking for, right? Now keep in mind there's a lot of symmetry in mathematics mimicking real life, right? So if you put squares on one side of the equation in the top, then you have to put squares on the other side of the equation in the top as well. If you put triangles in the bottom, triangles have to go in the bottom, right? So keep that in mind. There's symmetry in mathematics, and if you set up squares over triangles on one side, then it has to be squares over triangles on the other side, okay? And vice versa. If you put triangles on top on the other side and squares in the bottom, then triangles have to go on the top on the other side and squares in the bottom, okay? So what we end up creating is 2 different equations that we can now solve for the unknown. And the unknown, instead of leaving it blank in mathematics, we end up using an X, right? Basically saying X marks the spot. Right? You can use any letter you want, but X we use a lot in mathematics. One of the reasons is I think there's the least amount of words in the English language starting with X. So there's, you can't get confused with your units and stuff like this. You can use X, you can use Y, you can use Z, W. Those are the 4 common variables, letters that we use from the English language to represent an unknown, right? So what we're going to do now is try to solve this, right? And the way we're going to do it is use cross multiplication from what we did in series 3A, right? So what we're going to do is take the denominators on both sides and cross them over across the equal sign to the numerators on the other side, right? And that gives us, gets rid of the fractions for us, and we can go ahead and start solving for the x. So what we end up doing is taking the denominators down here and kicking them up. Down here, we're going to do the same thing, right? And that's all it takes, right? So what we're going to do right now is move to another wall and go ahead and do this cross multiplication and see what we end up with, okay? So the top equation that we had, we cross multiplied. We brought the x triangles up top and 3 triangles over to the top over here, right? So we've gotten rid of our fractions, right? Now what we have to do is get our triangles by themselves. So what we're going to do is divide this side of the equation by 2 blue boxes, right? And we're going to have to do the same over here, right? And once we do that, we know how to multiply fractions. We know what happens when you got the same thing in the numerator and same thing in the denominator. The 2 boxes kill the 2 boxes, right? And over on this side, the units kill each other, the boxes kill each other. So now what we have is x triangles is going to be equal to 3 triangles times 27 divided by 2. So what we can do is just combine, put the numbers together. So that's just a multiplication. That's just multiplying and division. And we've got triangles on both sides, so our units are consistent, right? So whatever answer we get over here, 3 times 27 divided by 2. 27 divided by 2 is 13.5. 13.5 times 3 is 40.5, right? And if you don't know how to do this, you have to go back to series 1 and figure out how to multiply fractions and how to break things down to prime numbers and how to do division, right? You could punch in your calculator, but it's good to do a little bit of mental math and keep your brain sharp, right? So what we're going to end up here is x triangles is going to be equal to 40.5 triangles. So what we end up having is x triangles is 40.5 triangles, and if you want, you can divide the triangles and get rid of them, right? So x is equal to 40.5, and that's our answer. What we're going to do is go to another wall and do the other equation, okay, or do the other ratio that we set up and solve for x, and you're going to find out it's going to be the same answer. So what we can do is do exactly the same thing we did with the last equation, right? We cross multiply, the denominators come up to the numerators on the other side, and what we're going to end up is exactly the same equation as we had as the previous one, and then we can go ahead and do exactly the same things as we did previously to solve for the unknown blue triangles, right? So what we end up with is exactly the same equation as we had last time. So we're going to divide both sides of the equation by 2 squares, right? So we got 2 squares in the denominator on both sides. 2 squares kills 2 squares. The squares over on that side kills that squares. We multiply out the numbers. 27 divided by 2 is 13.5. Times 3 is going to be 40.5. So we're going to have x triangles is equal to 40.5 triangles. We can just kill the triangles because all we're looking for is the x, right? The triangles is the units. We already know that. So x is equal to 40.5. So there's 40.5 blue triangles for 27 blue squares. And we just did a unit conversion. And what are the squares and the triangles? Well, they're anything you want them to be, right? Let's go ahead and, seriously, this is as simple as it gets when you're doing one jump, one connection. If you have the unit conversion table, okay, if you know the link between any 2 things, and if they ask you to convert from one to the other when you don't know one of them and you know the other one, all you do is you got to realize that your ratios are proportional. You set them equal to each other, use cross multiplication, and go ahead and solve your equations, right? It's that simple. Okay, what we're going to do right now is go ahead and do some real life problems, right? We'll just do a handful of them just so you get comfortable with them, and then we're going to jump ahead and start doing some more complicated stuff, the ones that you multiply all the fractions together. Okay, I'll see you guys in the next video.